Hey folks, welcome to another episode on Code with me. And in this video, we're going to be looking at setting up a Java Gradle project and adding Scala as an external dependency to Java. So before we go about this, let me give you a small difference between how the Java and Scala classes look like. So in the world of Java, you have the concept of classes and objects, which are nothing but instances of classes, right? So you have a class, and within the class you have methods, and these methods can be of two types: static or non-static. Plus, with any of these two combinations you can have a final. Okay, and apart from that, if you want to have an access to the static method, you can say class name dot method name. Let's just say static method name, right? Sorry. Yeah, so this is how you access a static method in Java. And to access an instance method, you have to say class name space c is equal to new class name. Basically, you create an instance of the class and say c dot method name. So this is how you do that in the world of Java. Now in the world of Scala, you have a different way of handling things. So what they did is they segregated out the static from the non-static. So what we will do here is, in Scala, there are again classes, there are case classes, then there is object and trait. Likewise, in Java, I missed out the concept of interfaces, which is basically uh, it basically contains unimplemented methods, and it is similar to abstract class, but the difference is abstract class can have contains both unimplemented and implemented methods, mainly used for inheritance. And here we have contains unimplemented methods. And recently, I think in post Java 8, I think you can have implemented methods as well in latest versions of Java, right? So this is how the world of Java works. You have classes and objects, you have static, non-static methods, which can be final or non-final. And final in the sense they are unmodifiable if you put a final keyword in front of a method or a variable. And you can have interfaces which will help you implement a certain behavior. It will have unimplemented methods which whichever class implements that interface will have to override those methods. It can also have implemented methods as of latest Java versions. Abstract classes are basically something similar to interface, but they're used mainly for inheritance purposes. So class A could be abstract and B could extend A and implement certain unimplemented methods of A. But A in itself could also have some implemented methods or have its own um, functionality. And then you have the access patterns, which is class name dot static method name for static, and instance created and using the instance dot method name for non-static. In the world of Scala, you have these classes: case classes, object, and trait. And if you want to access something in Scala which is static, usually you put that in an object space object name, and here you can have method def method name and some parameter type, let's say string, and return type, let's say string. So this is how your Scala world looks like. And you have object name dot method name to access the static method. So all the static methods usually go inside objects, and all your non-static will go inside classes. Def some method, okay, and you can have exact same thing. Probably no worries here. Yeah. So this can only be accessed by an instance of the class. So you will say val c is equal to new class name, and you can say c dot method name with whatever param you are passing, right? So this is the world of Scala, and here you will simply do object name dot method name param. So all the there is no static keyword in Scala. So whenever you want to say something as static, you define it within an object, and wherever you have non-statics, you can define that under class. So they have segregated this in the world of Scala. Traits are similar to interfaces, right? And case classes are basically POJO classes that you see, the ones with classes in Java. It have getter and setter methods, right? So those classes which are used to define your models in Java are basically called as case classes in Scala. So with this little analogy in mind, let's quickly get into creating a new project. Let's open Intellij. Let's set new project and let's call it code with me. Keep this box checked because we'll have everything committed to Git later on. So we'll just track it locally for now. Build system will be Gradle. JDK I have chosen Semero 21. It will be by default come with JDK 22 for you, but there might be issues with Gradle wrapper. Either you have to update your wrapper or you have to downgrade Java. So in my case, I did a slight downgrade to 21 because the wrapper supports 21. So I don't mind using 21 or 22. So I downloaded, click download JDK. You will get the Semero 21. Use Semero 21. Choose Groovy as your DSL. Groovy can be, and Gradle can be written in any of the languages here, Kotlin or Groovy. Let's go ahead with the default Groovy. Add sample code, which basically creates a new Java class for you, and add some sample code in it. Let it be there. And the wrapper and everything will be fine. This is going to be your hierarchy org.example.code with me, within which you'll have your system built. So it's a Java Gradle project with everything applied. So let's click create, and IntelliJ is working on creating it. Yep, it's created here. Yeah, so it's building the project. So let's wait a little while for a few seconds and it will build it. It's building the model, building repository, scanning files to index, and we're done. So this is the sample code it has generated for us. So this is the hierarchy, and as you can see, source main Java org.example, and this is your main class. So here you can observe that you have a public static void main, and there are two pieces of logic in here. Not a logic per se, but yeah, there's a system out printf. If you hover over this one, IntelliJ gives you a warning that printf is a redundant call. So let's try to make it println, and the warning is gone now. You can see a green tick here. And this is a for loop which is just iterating from 1 to 5, 1 all the way up till 5, and printing it out. So let's try to run this first and see what we get as the output. Mostly you will be seeing this print line statement followed by I1 to 5, as you can see here. So now let's try to create a Scala equivalent of this class. So what we're going to do is first go to build.gradle, and in this plugins just add id Scala. So in my earlier video I would have mentioned that you have to download the plugin for Scala. So if you have done that, you can go ahead and add plugins id Scala. And in the dependencies, we have to download the Scala Gradle dependency. So let's search for Scala Gradle dependency and scroll down, and you'll find the Maven repository link. Click that. within this, you will be redirected to some older version maybe, but you can click on the Scala library here and choose the latest one, which is 2.13.13 here in Maven Central. Click on this and you'll see this version here. There is Scala 3 also, but for this sake of tutorial, we'll be going with 2.13 versions because 3.0 has a lot of new features which is going to be a series or playlist of its own. So I'll probably do that later in a different tutorial. For this one, let's go ahead with 2.13.13. Copied. Let's put the dependency on top. Always keep your implementations on top and your test implementations later. So maintain this dependency hierarchy for logical segregation. Click on load Gradle changes so that it will build this library now for us, and it's done. So it's asking you to add new files to Git. Click don't task again because we'll select what we want to add to Git and what not. So we'll do that later. And we can see all these green files, right? So all these are Git tracked. Now if you click on external libraries, scroll down and you can see your Scala job 2.13.13 added here. So all good so far. So you have your Scala now inside your Java project as an external dependency. Now what we'll do is let's try to create a folder structure for our Scala classes. So click on main, new, directory. Automatically it shows the Gradle source set with Scala. Select that and right click on Scala, new. It shows now Scala class. So before we do that, let's look at the structure here. It's org.example. So let's try to recreate the same. Create a package org.example and let's create a new Scala class here. As I mentioned, objects are the one which will hold static, and I'll tell you the reason why we have the main as an object. So you'll call it as Scala main and it's asking us to add to Git. Let's click add for now. Now extends app. Now I'll tell you the reason why we are doing this. Let me finish this code first. So if we go back to main, you see that there are two pieces of code. Let's try to replicate in Scala. In the world of Scala, system.out.println is not required. You simply can put println and write whatever is here. So it's hello and welcome. Let's take this, put it here. Semicolon is optional in Scala. You put it, it will not mind. If you don't put also, it is absolutely fine. There's a for loop here. So let's do that in a Scala syntactic way. So it's 1 to 5 dot for each I implies print ln. What is there? I is equal to this. Let's take that, put the content here. That's it. So this finishes your Scala class for you, the Scala equivalent of this Java class right here. So few pointers. You have public class main, public static void main. So if you observe, main is always a static method. The reason is JVM tries to access main using the class instance, I mean the class name itself. So for JVM to find out and start the project, usually your main methods are defined as static. So that's why the public static void main here, which is the norm in JVM. And since Scala also runs on JVM, the main of Scala is also static, which is the reason why I'm encapsulating it within the object. As I have already taught you some time back in this video, objects will hold the static methods. Now extends app, because if you go to app is a trait, a special trait in Scala, which has the main method. So this implementation is automatically done at the root level, so you don't have to do anything. So when an object extends app, it automatically becomes the main in Scala. Any object that extends app will become the main in Scala. And println is, as I mentioned, we don't need system.out annotations. You just have to just say println. And this is a special case of syntactic sugar in Scala, which says 1 to 5, which if you can see there is less than equal to, which means it goes from 1 all the way up to 5, including 5. So if I want to stop before 5, I'll say 1 until 5. Automatically it goes from 1 to 4 and not include 5. But since we have 1 till 5 here is less than equal to, we're going to go with 1 to 5. So as you can see, this piece which you see here, right? If I click on extract as a variable, it's something called as range inclusive. So this is the special syntactic sugar of Scala, which allows you to create a list or a temporary list which will hold 5 elements and perform your operation on that. So instead of defining it like this, I simply did open parenthesis 1 to 5 close parenthesis dot for each element in 1 to 5 print this. So this is the concise code in Scala as opposed to the one that you see here in Java. And let's run this last but not the least. And let's look at the result. It's compiling. Build successful, and you can see the same output with Scala. Now apologies if this video extended slightly more than 10 minutes because I had to give you a slight explanation here to basically get on with this program. So thank you for watching this video. I hope you liked it. If you did, feel free to hit the like button. If you didn't, feel free to hit the dislike button. Comment if you want to ask any doubts on this one. I'll be able to answer to the best of my knowledge. And do subscribe to the channel if you want to see more such content. And I'll see you guys in the next video. Bye bye.